All right, boys and girls, we're back. This is part 2 of our exam review. This is exam number 1, which covers the first 3 chapters in your notes or your textbook. As you recall, after review number 1, we left off talking about significant figures and adding, subtracting, multiplying, and dividing, and how to round our answers off. Once again, this worksheet that you folks turned in, I think it was a homework assignment for you. You can pick up in your class's basket. I would strongly recommend doing that. If you don't want to do that, that's fine. It's up to you. You can check out the Canvas page for our class, and under the Files section, you can download this all over again and work through it maybe a second time, which might be helpful in preparing you for the exam. So quickly, with regards to significant figures, here's a measurement. That number ends in zeros to the right of the decimal, so that 0 is significant. So I'd say that that measurement had 4 sig figs. Here's a 0 between 2 non-zero digits, so it becomes significant. So this measurement has 6 sig figs. This one's pretty straightforward, 3 sig figs, 12 eggs in a dozen. Kiddos, that is a definition. You could even count it as a counted number if you'd like. Either way, infinite sig figs. This number here we can rewrite in scientific form, and I don't need those zeros at the end, do I? So these are the only 3 digits that are important, so we say that has 3 significant figures. That's also true if a number is smaller than 1. I could rewrite this number here in scientific form without these beginning zeros, so just those 3 digits are significant. Sometimes you'll see a number with a decimal point right at the end, and that's trying to tell you that the zeros before that decimal are significant. So this measurement would have 5 sig figs. When we add, remember, we look at the decimal place. So you can see in this one here, this is to the nearest thousandth, nearest tenth, nearest hundredth, nearest tenth. My least accurate is to the nearest tenth, so my calculated value was rounded off to the nearest tenth. We do that for parts B and C. Please don't just write down whatever your calculator says. Please think. You will not get any credit if the numbers are not rounded off to the appropriate number of significant figures. When multiplying and dividing, we don't look at decimals any longer, kiddos. We look at significant figures. So, in this measurement here, 10.19, I have 4 sig figs. 0.013, there are 2 significant figures. So even though my calculator spits out all these numbers, I'm only allowed 2 significant figures in my final answer. Please make sure you include units as well. If I multiply meters times meters, that's square meters or meters squared. Division, once again, the same rule as multiplication. You look at significant figures, not decimal places. And we talked about the metric system. And you should understand that in science we use the metric system. We don't use the English system when we make measurements. So we aren't going to use ounces, pounds, inches, or feet. We like to use the meter as our standard unit of length. The standard unit of volume is the cubic meter, but we kick that down to the liter, which, as you recall, is the same as a cubic decimeter. For the mass, we like to use the kilogram. You should know that that's 1,000 grams. For temperature, technically we use the Kelvin temperature scale, but we won't be using that for a few more months, so we'll be using the Celsius scale. SI stands for System International. There are prefixes in your textbook that you have to memorize. I expect you to know the prefixes mega all the way down to nano. So if I asked you what milli meant, you would say, okay, there are 1,000 millimeters in a meter. So milli means 1/1,000th. That's why I need 1,000 of them to make up a meter. We talked about the standard unit of volume being a cubic decimeter and how a cubic decimeter is the same as a liter. And we also talked about volume being length times width times height. Please make sure you know that. You use that in the laboratory to find the volume of a wooden block, and you should be able to do that calculation on the exam. Keep in mind that a cubic centimeter is the same as a milliliter. 1 cubic centimeter of volume is identical to 1 milliliter. Okay, once again, these prefixes need to be memorized before your exam. Please don't come into the exam without knowing these. I'm not going to provide them for you on the board or on a scratch piece of paper. You will not be given these. You have to memorize these, just like those 50 elements that you have to memorize before you come into class. Remember, when we convert from one unit to another, we put the unit we want to get out of on the bottom and the unit we want to get into on top. That way, the units that we put opposite each other divide out, or your math teachers might say cancel out. And now we're into our new unit, so long as the conversion factor is correct. Remember, the quantity on the top needs to be the same as the bottom. So it shouldn't make a difference if I offered you 1,000 milligrams of gold or 1 gram of gold. You don't care because it's the same amount, and that needs to be true for every conversion factor. Sometimes the conversion factor is on top, and we're multiplying by that number. Sometimes, as you saw in example 8, that conversion factor is on the bottom, and we divide by that number. Please practice these. In fact, it might be a good idea, now that you're at home, is you might want to take a piece of paper, and you might want to cover up these answers, just like that. And you might want to practice these on your own. If you can do the ones on your notes, I can guarantee you can do the ones that are on the exam. Remember, sometimes conversion factors take 2 steps. If I go from a prefixed unit to a prefixed unit, my first step is getting to the base unit. Then I hop out of my base unit and into my final unit. So sometimes these take 2 steps. We then converted from English to metric. We played around with that. The concept is the same, except the conversion factors aren't as pretty. They're not based on 10 any longer. I will give you these conversion factors. If I forget to write them on the board or put them on your test, please remind me. I'm happy to give you these conversion factors. You don't have to memorize them. Once again, the concept is the same. If I want to go from inches to meters, I'm going to go from inches to centimeters first because I know that conversion factor. Once again, I put inches on the bottom because I want to get out of it, centimeters on top, and then I go from centimeters to meters. If a number's on top, I multiply by it. If it's on the bottom, I divide. Once again, you can rewatch the videos to see how to use your calculators. We did this interesting one down here. That might be a fun one for you folks to cover up and try working on your own again. If you can do this example, you can do any that I put on the exam. We talked about density. Remember, density is mass over volume, not the other way around. Don't make silly mistakes. Make sure you put the mass, and I like it in grams, over the volume in either milliliters or cubic centimeters. Remember, it shouldn't make a difference because milliliters and cubic centimeters are the same. I might give you a question on the exam that's very similar to the lab that we did, where we found the volume of some marbles by water displacement. Or we found the volume of a wood block by measuring its length, width, and height. Or we found the volume of a liquid by using a graduated cylinder. Make sure you understand how we did that lab and expect to see questions like that on the exam. We talked about how we can use dimensional analysis in doing a density problem. Perhaps I can do one just for fun that we might see on the test. Let's say that you have a wood block that's 3 centimeters by 4 centimeters by 2 centimeters. Okay? And the density of that block, let's just make it up. We'll say it's 0.51 grams per cubic centimeter. So I want to know the mass of that wood block. I don't know what it is, so I'm going to calculate that. So let's see. I'm giving you length, width, and height. So aren't I giving you the volume of that block? So we can take 3.0 centimeters times 4.0 centimeters times 2.0 centimeters. And of course that would be centimeters times centimeters times centimeters, folks. That's centimeters cubed. I want to get out of cubic centimeters, remember, because I wanted the mass of that wood block, and into grams. So I'm going to use my density as a conversion factor. Doesn't that clearly say it's 0.51 grams per cubic centimeter? So my cubic centimeters cancel out, and I'm left with grams. Let's plug and chug that really quickly on my cheap calculator. You don't need to have a fancy one for all this work. So I'm going to take 3 times 4 times 2, and then I'll multiply by 0.51, hit enter. Looks like the mass of my block. Let's see, I have 2 sig figs all the way across. My calculator says 12.24, but I hope you agree that I would round that off to 12 grams. So make sure you folks can do calculations like that. That's about as tough as they get. Once again, think about what I did. Didn't I just multiply? And sometimes you're asked to divide. Alrighty, I'm not going to go through this last page for you. Folks, take some time to study. If watching these 2 videos is your definition of studying and preparing for the exam, you will come into my classroom unprepared. Please spend some time on your own. Commit yourself. You know, you can do hard things. Please don't give up. Work hard. For some of you, this is the first real science class that you've taken. I know you guys all have the capability of succeeding in this class. Make sure that you spend some time and review these materials. Let me give you a little history. A lot of the times the students don't have difficulties with the math. And you're probably saying, well, duh, that's obvious. All we're doing is multiplying or dividing. And that's true for the most part. What the students don't do is they don't study. They don't know what a physical and chemical property are. They don't know what intensive and extensive are. Maybe they haven't learned their 50 elements yet. Maybe they don't know what their conversion factors are yet. It's simple things like that where they have to just buckle down and learn them. I can't do it for you. That's something you need to commit yourself to and do it yourself. So please do it. Come and see me if you have questions. Let me give you a fair warning though. If you come and ask a question 5 minutes before the test, I'm probably not going to be much help. So come in before or after school. I'm happy to work with you. You folks have a great day. See you in class soon, and good luck. Bye-bye.